Hello everybody, I am Nadir Yildrim. I am the CEO and co-founder of Revolution Research Inc. So, at first I would like to start with my story. So I'm originally from Turkey, from the southwest corner of the Turkey actually. And I was a researcher in there and I was looking for a PhD position all over the world. And I come up with the University of Maine, and the next slide says why I came to Maine, why I traveled 5,000 miles. The first thing is the Advanced Structures and Composite Center, where we govern more than $160 million research. We service, more than 500 companies, over 400, over 40, international and nationwide awards. And also the School of Forest Resources with an experience over 110 years, and also differentiator scientist. So I did complete my PhD studies at the School of Forest Resources, and at the same time I did work at the Advanced Structures and Composite Center. So I kind of did a well education and also, a professional life. And then I combined these two skills and I developed and established the Revolution Research Inc., which is a research and product development company. This company won 2015 Humane Business Challenge, 2016 Top Gun Entrepreneurship Program, and we were the one Maine People's Choice Award for the Green Light Maine program. Also, we got awards from National Science Foundation and Environmental Protection Agency. So our research culture is that I call 3P and C. So it's problem, promise, prove, and communicate. This is our concept. So we determine the problem, focus on that, and we make a promise to solve this problem. And then we prove our technology, product, or idea, and then communicate. So we communicate with the companies, with the potential customers, and we make benefit from this product and the technology. So the problem that we are focusing was the petroleum-based products because they are bad for human health. They include hazardous chemicals, carcinogenic materials in their structures. And they are bad for environment because they are not recyclable or reusable. And most of them has these performance properties because they are crazily flammable and absorb water. As Revolution Research Inc., it was a problem for ourselves, but we need to be sure that it's a problem for everybody because we are trying to make a benefit from this stuff. And then we talk with stakeholders, people, different customer segments, end users, installers, and ask them the questions. And then outcomes of these interviews and the meetings was as we were expecting. They were looking for sustainable material, they were looking for light material with good performance properties, and they were still looking for cheaper material because they would like to make more benefit that I can understand. So, the next slide please. We made a promise, developing bioproducts using nanocellulose. So what's nanocellulose? It's a biodegradable, it's eco-friendly, natural polymer material that can be obtained from a variety of sources. It can be plants, trees, or sea animals. We are focusing on the trees, and we are going deep in their structure, millions times, and reaching these awesome fibrils or crystalline structures. These are really, really small, tiny fibrils, like 5 million times, 10 million times smaller than a regular apple diameter. They have an impressive thermal and mechanical properties. They are 4 to 5 times lighter than a steel. Although they have these remarkable properties, they have some drawback properties because it's still wood, it's still tree. So they are flammable and absorb water. As Revolution Research, we did work on these challenges and we solved these challenges. We applied our magic like the salt bee does. And we solved this problem and we made our products fire resistant and water resistant. So we are working on a couple projects. The first project is bio-based ceiling tiles developed under Environmental Protection Agency grant. So it is made from nanocellulose, biodegradable, offers minimum 3R value, which is thermal resistivity value. It's fireproof, water repellent, and offers this natural fibrillar surface design. The next project that we are working on is the multipurpose foam board. So this is eco-friendly, biodegradable alternative to petroleum-based ones, and it can be used for printing, options, hobby craft markets. It will be offering this water repellent, biodegradable, non-toxic structure, and also it will be offering self-assembling feature. So we will offer a technology that will provide a self-assembling. So at some point we will eliminate use of glues and chemicals. And the last project that I would like to mention is bio-based flexible composite foam boards for outdoor industry, which is here. I will throw it away. It is fully flexible and it will be used for bags and mats in the outdoor industry, and it's totally developed and it's easy to resize. We can produce it in any shape. So at this stage, what we are doing is we are communicating with bigger companies. We are going to take those conferences, meetings, classes. We are trying to be everywhere. And right now we are really have some strong interest from 2 to 3 big companies, large companies, and we are close to have good agreements. Next one, please. Nice place to start.
Does anybody have any questions? I'm happy to jump in, but I would love to hear if anybody else has any questions.
And I can't see anything.
Do you use this kind of technology for packaging?
We do use it, but we have limited amount of money and equipment and the personnel, so we are going step by step. But packaging is one of our goals, and it will be really soon. As you know, most of the styrene boards or styrene products banned from the market because of their, they can stay on the ground forever, like thousands of years. So it's a great and huge market. So it's an awesome suggestion, and we are working on it actually.
There's one here too. If you want to walk up, it's all there.
So what industries have been your early adopters of this material?
So insulation industry, construction industry, architects, and we are in contact with hobby craft market. And as I mentioned, outdoor industry, which is a strong industry as well. So these are 3 early adopters for our researchers actually.
I just couldn't hear what the third product was being used for, the outdoor foam.
Right. So it will be mostly used for backpack applications. So they are looking for flexible foams and stuff, and they are still using, unfortunately, non-biodegradable products. So we are going to offer eco-friendly version.
How do you make the nanocellulose non-flammable?
Sorry?
How do you make it non-flammable?
Non-flammable. We are applying some special treatments. We are using some chemicals that is approved by the Environmental Protection Agency, and we are making our products 3D fire retardant. So if you resize it, or if you change its shape, or get a small part, it's totally fire retardant. It's kind of fireproof. So of course I can't tell the chemical name, but it is a chemical that's approved by the Environmental Protection Agency.
Does the University of Maine hold any of the patents for these materials?
Oh, that's a good question. UMaine has many patents on this kind of materials, and we have some provisional patents as well. So, but UMaine has a strong, patents on this nanocellulose technology because they are one of the pioneers all over the world, actually.
So, how can you let that camping foam be biodegradable but also not just break down when you're sleeping on it?
That's a good question. Actually, you are kind of covering it with the textile. So it will be used in the textiles. So it will not be directly, interacting with the soil and enzymes. So that will be just totally fine. But if you make it, interact with the soil, with the enzymes and the life in there, and also the sunshine, all the effects will make it biodegraded actually. That's a good question. So for now, we don't want to be a manufacturer, because when you be a manufacturer, there are many other, teams needs to be created, marketing, production, sales, all of them, as you know. So we are in contact with 2 to 3 companies, and we are having our samples beta tested. So we would like to license the technology, and we will be still providing them, kind of lifetime research support, but the producers will be themselves or their producers. So I can't say in this place or in that place. It depends on our kind of customer actually. Yes, please.
Acidity of the foam.
Acidity? Oh, good question. We do some pH analysis on them. Actually, I don't have an exact number right now, but we are trying to make it acid-free, because this hobby craft market sells, especially like Elmer's product, they sell acid-free product. Actually, we are trying to be a competitor to their product, so it will be acid-free. And we are trying to work with Duke University. They have non-toxicologic laboratories, and we would like to make these products labeled for being non-toxic and non-allergic, actually.
Does NASA have any use for it?
Excuse me?
Does NASA have any use for it?
Ooh, I don't know if he have used that, but if they use that, but it can be used in there because it has an, as I mentioned, impressive properties, especially thermal properties, high temperature properties, I mean application temperature. It can be used, but I don't have that information right now.
Do you consider containerization, like moving, you say 4 to 5 times stronger than steel?
Actually, I said it is 4 to 5 times lighter than a steel. I mean, it's, you know, it is kind of as good as steel, but it's, you know, lighter than a steel. Actually, that's why the automobile industry also prefers to work with this material. So they are trying to decrease the overall weight of their cars. So they partially started using these materials.
I think you're going to call that good.
Thank you.